Module 16.2 Day 1. Proving figures are similar using transformations. Content standard. Given two figures, use the definition of similarity in terms of similarity transformations to decide if they are similar. Language objective. Work with a partner to list the essential components needed to prove a figure is similar to another. Confirming similarity. A similarity transformation is a transformation in which an image has the same shape as its pre-image. Similarity transformations include reflection, translation, rotations, and dilation. Two plane figures are similar if and only if one figure can be mapped to the other through one or more similarity transformations. A grid showing a map of the city park. Use tracing paper to confirm that the park elements are similar. Right? A. Trace the patio E, F, G, H. So then we have E, F, G, and H. Right? Turn the paper so that the patio E, G, E, F, H, G is mapped onto patio L, M, O, N. So then we want to do a rotation of 180 degree, and this is, we call it counterclockwise. Right? Describe the transformation. So we just did. What did this confirm about the patio? So then we know that this segment EF map onto LM, and you can notice that the order here is the same as here. Right? And then segment FH is mapped onto MO, and HG is mapped to ON, and segment GE is mapped onto NL. Okay? So then these two figures are similar by a rotation. Right, let's go to explain 1. Determine if figures are similar. You can represent dilation using the coordinate notation x, y map onto k times x, k times y, where k is the scale factor and the center of dilation is the center. If k is between 0 and 1, not including 0, not including 1, the dilation is a reduction. If k is greater than 1, the dilation is an enlargement. Example 1. Determine whether the two figures are similar using similarity transformation. So here we have the triangle RST and triangle XYZ. To map triangle RST onto triangle XYZ, there must be some factor K that dilates the triangle RST. So here we can say that in 0 go to 0 and 1 go to 1. So in here we say that in 0 go to some K factor times 0. So then it's still 0, and 1 go to some K factor times 1 equal to 3. So then that means that the scale factor must be a 3. And to test to see if it works, we can check this one with this 3. So 1 go to 3 times 1 give us 3. And negative 1 equal to 3 times negative 1 equal to negative 3, which gives us these 2 points. And similarly for t. Right? Okay, so here we can say that our triangle RST is dilated to our triangle XYZ. So then it's an enlargement. with the scale factor of k is equal to 3. Right? Okay, example B. Here we have a quadrilateral PQRS and another quadrilateral WXYZ. So to map PQRS to WXYZ, so then P is mapped to W, so then the coordinate for W is 5 and 5, and Q is to X, and R is to Y. So then the coordinate for R is 6 and 4, and the coordinate for Y is 12 and 9. And S is to Z, so then the coordinate for S is 6 and 2. So then to find the distance from P to Q, so from P to Q we can count the distance is 2, and this from Q to R we have 1, 2, 3, 4. And the distance from W to X we have 1, 2, 3, 4. And the distance from X to Y is 1, 2, 3, 4, 5, 6, 7. So then we see that PQ is coordinate to WX, so then 2 times PQ, since K is 2, so then we have 2 times 2 give us 4, so this one work out. But however, if we go from QR to XY, it doesn't work out. So then 2 times 4, which gives us 8, and it doesn't equal to a 7 here. So then no value of K can be determined that will map PQRS to WXYZ. So the figures are not similar. Right, okay, let's go to example 3. Determine whether the two figures are similar using similarity transformation and explain why. Right, so this is your term, so I'm going to have you guys work this out, and I'm going to give you guys the answer in a minute. So follow the order here. We know that L is going to G, so the coordinate for L is 1 and 2, and the coordinate for G is 2 and 4. So we know that the K factor is 2. All right, let's see if it works for M. So the coordinate for M is 4 and 2, and M will go to H, so then the coordinate for H is 8 and 4. So then 2 times 4 is 8, and 2 times 2 is 4, so it worked. And let's go for N. Is 4 and 6 will map to J. So the coordinate for J is 8 and 12. So then 2 times 4 is 8, and 2 times 6 is 12. The last one is O, so the coordinate for O is 1 and 6, and it will map to K, and the coordinate for K is 2 and 12. So then 2 times 1 is 2, and 2 times 6 is 12, so then the K factor is 2, and let's see if the distance will work. Right, so then from L to O is 4, this is also 4, and L to M is 3, and this is 3. So the distance for the larger quadrilateral should be double. Right, so here we have 1, 2, 3, 4, 5, 6. And here we have 1, 2, 3, 4, 5, 6, 7, 8. And we have 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. So then my mistake, this should be a 3. Right? So then this is 3 times 2 gives us a 6, and a 4 times 2 gives us an 8. So then it works. So then these two are similar. Well, in example 4, we're mapping the triangle JKL to the triangle MNP. Well, immediately we know that they do not preserve the angle. Also, they did not preserve the distance. So then these two are not similar. Oops. Okay, and for number 5, we're mapping CDE to TWVF. So then here we have CDEF map onto TUVF, right? So then these two lines are parallel and these two lines are parallel. Okay, so then that means that, and these are also parallel lines, so then corresponding angles are congruent. Right? Okay, so then the angles are preserved. So the distance from T to F, we can count. So there's 1, 2, 3. And the distance from C to F is 1, 2, 3, 4, 5, 6. So then the scale factor is 2. And we can see that for the diagonal as well. Right, so then these two are similar. Okay, so then that's the end of 16.2 day 1. So your assignment is to work on number 1 through 6, and we have a new HRW. Also, we need you guys to copy down 16.2 day 2 notes.